Pascal's triangle, just to show Pascal's triangle, I'll explain to you why it comes in. But honestly, the binomial theorem, if you just use the binomial theorem, you don't need Pascal's triangle, but I just show it just in case for some reason it randomly would pop up on a test or something. I've never seen it, but good. So Pascal's triangle is this triangle, and I'll show it to you and I'll explain why it even has any relevance as we go along and do these questions down here. But Pascal's triangle is a triangle that he figured out that if you start off with a 1 up here, and then you go 1, 1, so that's the second row. The third row is going to be a 1. It always has 1s on the outer edge of the triangle, and then you add the numbers up in between. So by the third row, we only get to add them up. So here we go 1, 1, and then here we go 1. We will start off with a 1. Then we go 1 plus 1 is 2, and then we end with a 1. Then we go 1, and then we add them up. 1 plus 2 is 3. 2 plus 1 is 3, and then we have a 1. Okay, then we have a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then we end with a 1. Then we start with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and with a 1. And you can just keep going. Okay, that's Pascal's triangle. I'll explain to you why it actually is helpful when we start getting through the next step. Okay, so a plus b to the 5. Before binomial theorem, because you don't even know binomial theorem, what would you do to get this expanded out? A plus b times a plus b times a plus b times a plus b times a plus b. Foil, foil, distribute, 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 collect like terms at the very end. It would be horrible. So when we go to do binomial theorem and you're like, oh, this is so long, think it could be worse. If we didn't know binomial theorem, we would be going a plus b times a plus b times a plus b times a plus b times a plus b, foiling, foiling, distribute, distribute, collect like terms. Could be worse, right? So think about that. I'm forewarning you because you're going to be a little whiny about the fact that you're using binomial theorem. Binomial theorem, great thing about it, is it's given to you on your formula sheet, so at least you don't have to memorize it. It's in this little deep dark corner over here, because everything from this unit is underneath perms, comms, and binomial theorem. This down here is binomial theorem. So it says, in the expansion of x plus y to the n, so it only works if it's in the expansion x plus y to the n. So we're right up here. Okay, in the expansion x plus y to the n, it says, written in descending powers of x, the general term is tk plus 1 equals nck x to the n minus k y to the k. It looks overwhelming, but it's not, I promise. So that's the formula they give you on the formula sheet. If you can put a binomial into the form x plus y to the n, you can expand it out using binomial theorem. Okay? So we're going to look at a. We remember we could expand that by going a plus b, a plus b, a plus b, a plus b, a plus b. And then we'd have to foil, we could distribute this into one bracket, and then we'd have trinomial, trinomial, and then we'd have to distribute a trinomial. And then in the end, we have collect like terms. So we could go that route. Doesn't sound like fun. 5 is kind of reasonable. When this is like 11 or 12, that sounds extremely not reasonable. Okay, so let's think about it. So we need to have it in the form x plus y to the n. We do. This is our x plus y to the n. Okay. So we have x plus y to the n. So our n is 5, our y is b, our x is a. So wherever we have an n, we're going to replace it with 5. Wherever we have a y, we're going to replace it with b. Wherever we have an x, we're going to replace it with a. Okay? So let's start expanding. We use the formula. The formula is nck, it's this, nck x to the n minus k y to the k. So we're going to go n. N is 5. C. For the first term, k will always be 0. And then we have to keep going till we get to k equal to n. So we're going to have to go k equals 0. Then we're going to have to do the next one, k1, k2, k3, k4, till we reach k5, because we have to keep going till we reach the same amount of k's as the variable n. So n is 5. We're going to have to keep going. So it's going to take a lot of room. So maybe write small. So we're going to go 5ck. So remember the formula is n c k x to the n minus k y to the k. That's what we're going to plug in. We have to do this for every single term. There's going to be 6. So we're going to go 5c0 because term 1, k is 0. K is always 1 less than the term you're finding. So if you're looking for term 5, you're going to use k equals 4. Or if you're looking for term 2, you're going to use k equals 1. So k is always 1 less than the term you're finding. So term 1, k is 0. Okay? Now x, so we have to put in an x. X is a. N is, so n minus k. So n is 5, k is 0. Right? And y is b to the k. K is 0 for this term. And we are done term 1. Well, we're not done it, but we have it in binomial expansion. Now we do term 2. What's the only thing that changes for term 2? The k's become 1s. Everything else stays the same. So now we're going to go plus, because we have to get term 2. 5c1, a to the 5 minus 1, b to the 1. So the only thing that changes is the k. Term 3, what's going to be? What's going to change? The 1 is a 2. So plus 5c2, a to the 5 minus 2, b to the 2. Remember I told you we have to keep going till k is the same as your n? So we're going to have to keep going till k is 5. So for the fourth term, k is 3. So 5c3, a to the 5 minus 3, b to the 3, plus 5c4, a to the 5 minus 4, b to the 4. And then our last one, plus 5c5, a to the 5 minus 5. Oh, good, my computer's going off again. B to the 5. And we're done. So we have to start at 0, k equals 0, and we have to go till k equals what n is. Okay? Now let's think about this. There's 1, 2, 3, 4, 5, 6 terms, right? There's always one more term than the value of n. Why? Why is there always one more term than what n is? So n in this case was 5. Why is there 6 terms? Yes, because term 1 is 0, and we have to keep going till we hit n. So if term 1 is 0, and we have to keep going till we hit n, we're always going to have one more term than n, right? K equals 0, k equals 1, k equals 2, k equals 3, k equals 4, k equals 5. So number of terms, that's of star, number of terms is always equal to n plus 1. Right? So it was 1 more than n. So if n was 5, we actually had 6 terms because we start off with k equals 0, right? The other thing is, whatever term you are looking for, k is always 1 less. So if I'm looking for term 6, K is 5. If I'm looking for term 1, K was 0, right? So K is always 1 less than the term you're looking for, and the number of terms is always 1 more than n. Very important that you know that, because when they ask stuff in the diploma, sometimes they'll give you a binomial, like a plus b to the 5, and they'll give you like 7 statements, and they'll ask how many are true. If you don't know that the number of terms is 1 more than n, then you'll get that statement wrong. If you don't know that when you're looking for term 3, k equals 2, you get that statement wrong, right? So you have to know everything really well. So we're not done, obviously. So we're going to go 5C0. 5C0 is 1 when you put it in your phone, in your calculator. So 5C0 is 1. A to the 5 minus 0 is a to the 5. B to the 0 is what? Anything to the power of 0 is 1. So you don't have to write it. Whenever you have 5 and you choose nothing, there's only one way you can do it. You can have 5 things and you choose none of them. One way, right? If you have 5 things and you choose 1, there's 5 ways you can do it. You can pick each of the 5 things. So it's going to be plus 5, bless you, a to the 4, b to the 1. So we don't have to write b to the 1. We could just write b, but I'm going to write 1 because it's a to the 4, b to the 1. 5 choose 2 is 10. A to the 3, 5 minus 3, b to the 2. Plus 5 choose 3 is the same as 5 choose 2, are they not? Remember, because it's the difference between the two. So it's 10 again. A to the 2, b to the 3. 5 choose 4 is 5. A to the 1, b to the 4. And then 5 choose 5, you just pick them. Say I have 5, you take them all. So that's one way. A to the 0, what's a to the 0? 1, so I don't have to write it. B to the 5. So this is the expansion. So if I took a plus b to the 5, expanded it out all the 5 ways, expanded those out, collected like terms, I would get this. So yes, this seems long, but imagine expanding that out. Imagine that you have a plus b to the 12. Good luck. Godspeed. I think I would mess up somewhere. That's just done. So if I took this up here and I expanded this out, collected all my like terms, I would get that. Okay? Look at the coefficients of this. 1, 5, 10, 10, 5, 1. Look at this. 1, 5, 10, 10, 5, 1. So what some people do is they'll follow the back part of the binomial theorem, and they'll go, oh, okay, we're in the 6th row of Pascal's triangle because n is 5, so I need 6 terms, right? So then I have to find the Pascal's triangle line that has 6 terms, and then just put those in front instead of going 5C0, which is 1. I promise you, in my head, I don't know, maybe in yours it's easier. I just like 5C0 because I'm going to have the 0 to plug into here anyways. So why wouldn't I just put this part instead of writing out Pascal's triangle till you get to the row that has the proper thing and just put those as the coefficients? Like, that doesn't seem easier to me. But some people teach that way. I do not feel that is easier. I feel you're going to have to use the 0 and the 1 anyways to be able to plug it in. So why wouldn't you just put this at the front like the binomial theorem? So this is all you're going to see of Pascal's triangle. I'm never going to talk about it again, just so you know. I'm showing it because that's where this comes from. So Pascal realized that the coefficients, when you expand binomials out, actually follow a pattern. Yay. And that is the end of that. Okay. How is this one a little bit harder than that one? Just a teeny bit harder. Yeah. What form do we need to be in so we can fill into binom? X plus y to the n. So if it's not a plus, you just have to make it a plus. So this is what you do. You just go 3a plus negative 2 to the 4. That's it. It's not tricky. That literally is all it is. You just have to remember to do that. So the common error on the diploma is going to be that people are going to go 3a and 2. They're going to treat this as their x. They're going to treat positive 2 as their y. And they'll have that answer there. It's not correct. This is your x. This is your y. That is your n. So your y is actually a negative 2, which changes the whole game. right? So you have to remember that if there's a subtracted sign in there, you have to go plus and minus. So how many terms are we going to have in the end? 5, because n is 4. We're going to have one more, right? So let's try it out. N, 4, C, 0, because term 1 is 0, x, so 3a to the n minus k, so 4 minus 0, and then b is, or x is negative, or oh my goodness, y is negative 2 to the k, 0. Then plus, the only thing that's going to change on the next one is all these zeros are going to become 1s, right? 4c1, 3a to the 4 minus 1, negative 2 to the 1, plus, now all the 1s are going to become 2s, 4c2, 3a to the 4 minus 2, negative 2 to the 2. Now the 2 is going to become 3s, 4c3, 3a to the 4 minus 3, negative 2 to the 3, plus 4c4. It's going to be my last one because now they're the same, right? 3a to the 4 minus 4, negative 2 to the 4. Rarely on a diploma do they actually make you expand the whole thing. They'll say, what's the third term? What's the fourth term? What's the seventh term? Well, if they ask you for a specific term, k is 1 less than that. So if they ask you for the sixth term, you'll just do k equals 5 and just do one little term. Okay? So four, choose 0. If I have 4 and I choose none, there's one way to do that. And we get 3a to the 4. This is where people err. We're going to have to do 2 more. We're going to have to do this answer, and then we're going to have to keep going. Because you have to remember to raise the 3 to that exponent as well, which is what everyone forgets. So it's 3 to the 4, a to the 4. 3 to the 4, a to the 4. Negative 2 to the 0 just cancels. Plus 4c1 is 4. Now 4 minus 1 is actually what? This is a 3, right? So we're going to go 3 to the 3, a to the 3. And then it's negative 2 to the 1, which is just negative 2. Remember, when a negative is raised to an odd exponent, it stays negative. When a negative is raised to an even exponent, it turns positive, right? Then plus, what's 4c2? 6. 3, now this would be 2. So 3 to the 2, a to the 2. Negative 2 squared is positive 4. If you go negative 2 squared in your calculator and you do not put negative 2 in brackets, it will tell you every time it's negative 4. Because it's thinking you're going negative 2 squared, which you're not doing. So whenever you want to raise any negative number to an exponent, you have to go bracket, negative 2 bracket, squared, and it'll turn it to a positive, which is what it actually is. If you forget the brackets, you're going to get it wrong every time. Plus, 4 choose 3 is 6. No. Yes. 4 choose, what am I on? 6 and then 4. I don't even know which one I'm on. I'm this one, right? 3a to the 1, so it's going to be 3 to the 1, a to the 1, so I'm just going to write 3a. Negative 2 to the 3 is negative 8. 4 choose 4 is 1. 3a to the 0, so that just cancels. Negative 2 to the 4 is positive 16. Now we have to put all coefficients together. What's 3 to the 4? 81? I think. So we're going to go 1 times 81 is 81. A to the 4. Plus, now all the coefficients together. So 4, and then 3 to the 3, and then negative 2 all have to be multiplied together. So 4 times 27 times negative 2 is what? Negative. So if I go plus a negative, what could I have done instead? Just write a minus sign. Negative, what was it? A cubed. Plus 6 times 9 times 4. So 24 times 9. What'd you get? A squared. And then 4 times 3 times negative 8. It's going to be negative 96 plus 16. Makes sense? It takes a long time, but like I said on the diploma, rarely would they actually make you expand the whole thing. They'll ask you questions about it. They'll say this has how many terms? Well, n plus 1. This has this term has k is equal to what? Find this term. What is term 7? Like they'll make you do it that way, which is the constant term. They ask stuff like that. This is the formula that explains it out, and then you consider it to do that way. Flip over to the next page. Let's define the fourth term. Fourth term just means what? K equals, first term k equals 0. So fourth term k equals, first term k equals 0. So fourth term k equals 3. One less, right? First term k equals 0. So when because it's going to be like, are you going to guess it to be 3 or 5? Those are going to be your options. So always think first term k equals 0. First term k equals 0. Then you reason that it has to be one less. Okay, that's the way I always do. Okay, it has to be x, y equals number. Well, we have x, and y is actually y, and 8 is n. Our formula is always n c k x to the n minus k y to the k. We know x, we know y, we know n, we know k. We can figure out the term. So n is 8. C, k is 3. X is x to the n minus k. So 8 minus 3. Y is y to the k, which is 3. Now we can just figure it out. What's 8c3? 8c3. X to the 8 minus 3, so 5. Y to the 3. Way easier when they ask for just one. Well, way shorter. I don't know about easier, shorter. Find the third term. What's k equal? 2. So we have k equals 2. What's my x equal to? Remember, it has to be x plus y to the n. So it's x plus negative 5 to the 7. So x is 2x. Y is negative 5. N is 7. Then we can fill it in. Right? This is our x. This is our y. This is our n. And our k is 2 because we're looking for the third term. So it's going to be n, 7, ck, 2, x, which is 2x, to the n minus k, so 7 minus 2, and then y, which is negative 5, to the k, which is 2. What's 7C2? 21. So we're going to get 21 times, now 7 minus 2 is what? 5. So we're going to have to go 2 to the 5, x to the 5. Common error is not putting that coefficient to the actual exponent, okay? 2 to the 5, x to the 5. And then negative 5 squared, positive 25. Then I have to multiply coefficients. So 21 times 2 to the 5 times 25. 2 to the 5 is 32. So 21 times 32 times 25 is a big number. X to the 5. Find the middle term. The easiest way I feel like finding the middle term is state all my k values and then just circle the one that's in the middle. So for term 1, k equals, so all the k's I'm going to have for my options here are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are technically all the k options I'm going to have if I expanded this whole thing out, right? I'd have to go k equals 0, 1, 2, 3, all the way to n, and n is 10. Which one of those is in the middle? If you don't know, this is what I do. 1 for 1. K equals 5 is the middle one. Use k equals 5 to do the question. So for this one, x equals a, y equals b, n equals 10, and k equals 5. So we do 10c 5, a to the 10 minus 5, b to the 5. What's 10c5? A to the 5, b to the 5. Keep in mind too, you guys, your exponents should add up to the n, right? So 5 plus 5 is 10. Like this one here would end up being x to the 5, so your y would go away, so that'd be okay. When you have exponents, though, with letters, they would add up to the exponent. Like x and y here, they add up to the exponent. 4, 5, 6, 7, we're going to do tomorrow because they're more advanced. Your homework is a bit of this, not all of it.